Hello and welcome. Today we're going to be looking at the equations of inverses. So if you remember inverses, basically that just means that the points on the graphs of the two equations are exactly the same, only all the x's and y's are reversed. So if we're looking at an equation, or if we're looking at something as an equation and we want to find its inverse, then we're basically just going to switch the positions of x and y and then solve to get the new y by itself. So if I'm looking at this first example, I'm told that y equals 4x plus 8. So if I want to find the inverse of this equation, I'm going to take the x and y and switch their positions. So that I have x equals 4y plus 8. And then I'm going to solve the equation to get the y by itself. So as we normally do, we're going to use a minus 8 to cancel out the plus 8, which will give me x minus 8 equal to 4y. Then we will divide the 4 on both sides. Then to simplify the left side, we're basically just going to distribute this 4 to both of these values. So if I take x over 4, remember that there's technically a 1 in front of the x. So I'm going to have 1/4 x. If I divide negative 8 and 4, it's going to give me a negative 2. Now the y is by itself. So my inverse equation is 1/4 x minus 2. And we may also see this written as y inverse equals 1/4 x minus 2. For this next example, the first thing that we probably want to do is remember that f of x is the same as y. But other than that, the steps for this are going to be the same as they were in the previous example. So the y and the x will switch places. So I should see an x over here, a y over here, and then the rest of my equation should look exactly the same. So I'm going to take x equals 7 minus 5y and rearrange it so that the y is by itself. So we'll start by subtracting the 7 on both sides. And then we will divide everything by negative 5. And just like last time, we're going to distribute the negative 5 to both the x and the negative 7. So if we divide the 1 and the negative 5, we should see negative 1/5 x. And then if we divide negative 7 and negative 5, we should get a positive 7/5. So our inverse equation has been solved. So for our final answer, since they used f of x instead of y in the beginning, we'll go ahead and switch it back to f of x. Once again, that little negative 1 represents the inverse. So my final answer will be f inverse x equals negative 1/5 x plus 7/5. So in our third example, we'll notice that we're given a quadratic equation, but that doesn't really change like the steps that we're going to follow as far as setting the problem up. It will just change the steps slightly when we go to actually solve to get the y by itself. So we're still going to switch our x and y first. So we should see x equals 2y squared minus 6. And then we'll go to get the y by itself. And so the beginning of this process will look the same. There's just going to be a little bit of an extra bit at the last part. So we're going to add 6 on both sides. Then we're going to divide everything by 2. We're still going to distribute that 2 to the fraction on the left side. So we should see a 1/2 x plus 3. And then the little extra piece is that we need to do a square root to get rid of the exponent on the y. And then since we are taking the square root of a variable, we need to remember to put the plus minus in front of the square root before we submit our final answer. So my inverse is going to be positive or negative square root 1/2 x plus 3. So for our next example, we're going to look at plotting a function and its inverse on a graph. So the first thing we're probably going to need to do is figure out the actual equation of the inverse. So we're going to, once again, switch, then solve. So I should see my x over here and my y over here. Then we'll solve to get the y by itself. So my inverse for this equation is going to be 1/2 x minus 2. So what I'm going to do now is go ahead and graph that equation as well as the one that I started with, so I can see like if I notice any trends or patterns in the picture that I'm given. All right, so we know that we were given the line y equals 2x plus 4, and we got that our inverse was 1/2 x minus 2. And so to illustrate what we're looking at here, I'm going to go ahead and graph the line y equals x so we get that nice little diagonal running through the middle. So what I want to point out here is that just like in our equations where the x's and y's switch places in order to solve for the formula, the points on the graph match up in the same way. So in the original graph, my line hits the y-axis at 4. In my inverse graph, my line hits the x-axis at 4. In my original graph, I have an x-intercept of -2. So when I do the inverse, that becomes the y-intercept. And I should be able to pretty much find any point on the graph, and those coordinates should have their x's and y's switched. So for example, if I go over here to 8 and 2 on my inverse graph, I should be able to scroll up and see that the original graph, had the point 2, 8. And then if I go down to the bottom, it's the same idea. On my original graph, it looks like I'm at -6, -8. On my inverse graph, the blue line, right, -8, -6. So all the points on the two lines are the same, but the x's and y's have all switched places. And so the reason I graphed that green line is so that you can see that all of the points on the red line are just reflected across that green line, right? So no matter where I am, that green line is exactly in the middle of the red line and the blue line. And so to answer these bottom two questions down here, we need to remember way back to the beginning of the course, we talked about whether or not something is a function, right? So we said that a relation is a function as long as none of the x values repeat when we're looking at the graph or when we're looking at a table. So since our red graph was basically just a straight line, none of the x values overlapped, so therefore we started with a function. The inverse was also a function because it was also a straight line. So we can go ahead and put yes to both of these. For our final example, we'll go ahead and do the same steps as we had seen before. So my inverse for this one is going to be plus or minus square root x minus 1. So I'm going to go ahead and put those on the graph. So here's our original equation. And then since our inverse equation had both a positive and a negative in front, I'm basically just going to put those in separate rows. So I should see square root x minus 1 to represent part of the inverse, and then negative square root x minus 1 to get the second part. So what we should notice is that once again, the green line runs through both of our curves. The x and y coordinates of the different points have just been flipped around. So our y-intercept on the purple line is at 1, and that turns into the x-intercept for the other graph. The biggest difference here is that now our inverse has points that overlap with their x-coordinates. So that means that our inverse is no longer a function. So the original graph was okay, but the inverse graph was not because it failed our vertical line test. So just because we start with a function doesn't necessarily mean we end with a function. So you'll just have to pay attention to the graph and be careful from that standpoint. All right, guys, that's all I have for this one. I will see you next time.